All right, thanks everyone. We are going to save questions for the end. That way we can go ahead and hand the microphone out. Unless it's really important, then DeShaun will answer. We'll have a microphone here if you need to give it around to somebody. With that, you're in for a treat. My good friend, DeShaun Carter, fellow Spring Developer Advocate, also co-host of the Spring Off Stars podcast with me. Man, I love watching DeShaun. He comes with the energy. I'm looking forward to this. Let's go, DeShaun.
I'm going to tell you that I inherited this time slot, this session from somebody that I really, really respect and I have high regard. And I spent nights tossing and turning, including last night. How could I ever give this justice? Because Chris is amazing. And yeah, I'm happy. Today's a good day. I'm going to introduce myself quickly. My name is DeShaun, T-R-O, yeah. And I'm a Spring Developer Advocate, and there we are. 981 days in this role. Before that, I did other stuff. I worked for a company called Redis, if you're doing data. Before that, I worked for Pivotal, VMware. I was a solution architect. This is the key. A lot of what I do is help customers, help people get over hurdles. I love my job. I love seeing the light bulb moments and the smiles and the joy. I get to see that most of the time, most of the week. I get to teach somebody something that helps them. And that makes me love my job. Before that, I did some other stuff. I worked for a company called Garmin. I'm a big fan. So that's me. I've been around. I love this job. And this talk, it's kind of hard. It's kind of hard to figure out, where is everybody at? What's the level? So I did a little sample. We have some new folks. I'm going to ask for some hands. How many people have used Spring Data before? Spring Data. That's really good. Fantastic. That helps me out so much. How many have used Spring Data with Java 21? Less hands. Okay, less. How about with Java 17? Yeah. Okay, good. So the way I was going to approach this was hey, I had some ideas of the things that matter the most to me, things that help me out. But based on my sampling, it seems like we have a lot to learn. Does anybody in here have a secret, something that they like about Spring Data that maybe the rest of the ecosystem doesn't know? Do you feel like you've found a cheat code with Spring Data? If you feel like you've found one or two cheat codes in Spring Data, raise your hand. Jonathan, of course. That's good. One of the maintainers. Yes, he knows the maintainers. They're all on the same team. So I have some that I thought were valuable. I'm going to save this for later. We'll come back to that. Spring Data. Spring Data is a project. The big thing about Spring, what mattered to me and how it helped me was if I was working on Oracle one day and working on Postgres the next day and working on Redis the next day, I felt pretty comfortable because Spring Data provided that abstraction where I felt, hey, I'm going to pop out this library and I'll pop in a new one. I'll give the new default data store driver and Spring will do the rest. Spring Boot will do the rest. And that was great. I felt comfortable. Anybody else feeling that? Looking for feedback? Yeah. This is benefit. We're seeing more of that with Spring AI, and I hate to say AI, but all these things kind of come back to being data in one way or another. When I think of Spring Data, I think, hey, where am I going to put my data? How am I going to use it? How am I going to get leverage out of that? Where's the value going to be? Spring Data's got tons of opportunities. One of the questions was how do I get beyond just a database? What are the options? There are drivers. There are implementations that come from the community that get added into Spring Data all the time. I'm going to jump over here. And one of the interesting things, it seems like it wasn't that long ago, a few years ago, JSON was the big thing. Every database everywhere we have JSON support. And now where am I going with this? What is it now? Every database now has vector support, right? So on Spring Data, inside of the Spring ecosystem, we have, I think there's 12, the last time I checked, 12 different vector stores for your data. And I promise I'll bring this back. But one of the big questions that I always get asked around how do we take the data that we have and train our AI? This is a popular thing. How many people have said, oh, I would like to use AI, but I want to use my data. How do I train it on my data? This is a common question. I get to work with customers just like you all the time. And how easy it is to take the data that you have today, your tables, your whatever it is, and vectorize that into a vector store and use it with existing LLMs. This is like a massive, easy thing to do. And we saw Josh do it in just, his little session. I think he had 6-minute slot where he vectorized his database. It was only 16 or 15 rows, but he vectorized it in just a few lines of code. And then he could use that against any one of the LLMs. He used it against OpenAI. But that is possible. That's where we are today. That is the big topic. So the data conversation has become higher value. It's become a bigger conversation. And I kind of joke sometimes. Their ETL that, hey, we're going to pull out some data, we're going to transform, we're going to put it into someplace else. There's engineers in my career. Maybe I was like, oh, he's just an ETL engineer pulling billions of rows off of mainframes and putting it into another database. Oh, that's all he does all day. But guess what? Those ETL engineers are now like, ha. I know how to move the data from here to there. Things have changed, right? The right answer changes over time. The cool job also changes over time. The value of our documentation. I did the same thing with, oh, you just write tech documentation. Well, come to find out that all of these LLMs are being trained on our tech documentation. So your documentation is now, more important than ever, right? So there, I'll come back. That was my little branch off on AI, and I'm going to bring it back. We have the vector databases. This is easy. But yeah, Spring Data, it provides those abstractions. And whether it's documents, document stores, vector stores, or relational databases, that abstraction layer and that comfort level, the abstractions are consistent no matter which platform, which data store you're running on. You can have, if you've used Oracle, you can feel pretty comfortable that you know what to look for if you decide to use one of the vector databases. That makes sense? So that's kind of the level set. I'm going to add one piece in just the background, where I'm coming from. I spent time really focused on data. I spent time really focused on how do I get my transactions. Actually, let's just jump in. I think that's the first one. The abstractions, I covered that. One of the questions, somebody's like, hey, I don't use Spring Boot. Did you know that you can use Spring Data with or without Spring Boot? So there's a cool example of you don't have to have Spring Boot apps and have all of the nice auto configuration. You can use Spring Data with any of your projects. You can get that same level of abstraction. This was actually the first kind of exciting piece for me, was the ability to bring in Spring to provide all of my cool data interactions. The first times I was using it, object relational mapping. I was back with the XML config, so I dealt with that. But Spring was a part for security and for data. I leveraged it every place that I could, every project that I could. Thank you for the nod, right? We've been there. But this bomb, you can actually bring in Spring Data. You can use the bill of materials. We get one of these with most of the projects under the Spring umbrella, to bring in one of the projects into an existing project to leverage the benefits that Spring provides. That's the first hidden gem. If you're taking score, if you want to keep track and then, hey, I know some hidden gem, that's number one. That you can bring in Spring Data into your other projects and you'll use the bill of materials. Good? Nods? So far, we're checking boxes. Let's keep going. It is 2024. 2024, right? Yeah. My children will never deploy ActivePassive. This idea, it's from my rough upbringing. We didn't have money for a second data center to just sit there, idle, in passive mode. It's a thing. It happened over time where, hey, we're going to deploy, we're going to use one data, all active traffic's going to go over here, we're going to do all writes over here, and you'd have a second data center that's just idle, just waiting. Maybe you would do a blue-green deploy, like, hey, we're going to do our updates over here, make sure it works, and then we'll flip the switch. But I don't have that kind of money. I've never had that kind of money. I don't have cloud money. I like to say I have Raspberry Pi money. I have Raspberry Pi. That's my home lab. And my children will never deploy ActivePassive. One of the other benefits of Spring data in general, is we've come a long way. And the conventions that are provided and the starters, et cetera, make it so that I can actually live an active lifestyle. So in my house, I have multiple internet providers and I have multiple data, nice subnets, different segments, so we can do some interesting things. And one of the most interesting things is to say that I can go and pull a plug on a computer or on a database. I can shut it down and know that things will still work because I can have an active implementation. I can write where I need to write so that the money that I'm spending on my infrastructure is being used wisely. It always comes down to money, right? We can write it in PHP and spend a lot of time and money that way too. But money is kind of an important piece. One of the things I got from Marcin and Josh Long is like the idea that the role that we're in is to help the company in some way, shape, or form. You're getting paid to deliver money, value, savings, time, whatever it is, and to take that seriously. And if you're doing anything, there's a data element involved. So far, so good. My children won't deploy ActivePassive, and Spring Data has a lot of implementations to help you. Spencer Gibb was up here earlier, and we've had this conversation many times. Do you guys remember the web scale, but is it web scale MongoDB meme that went around? No, some. This idea that there are databases, there's data stores, there are implementations that out of the box, you can deliver active. You can say, hey, I want to deploy. I'd like one region over here in East, and I'd like one region over in Australia. And you don't have to do any configuration. And your configs, your bindings, will set you up in a way that you can do active. You can write. And if one region goes down, all of your data is still safe. This is cool. There are implementations like Gemfire, where if you're a global company and you've got data centers all over the world, maybe when you're in this region, you don't want anybody in another region accessing that data. You want to leave that data in your region. And Gemfire has some of these things built in where you can say, hey, only if you're being accessed from this region will you return results from this region. The data conversation makes an active deployment really interesting, but you can still deliver active and still segment your data so that only one region can get it. It might have a little bit larger latency if it's pulling from the wrong region, but you can still do that. I like to say that latency is the new downtime. Does that make sense? Even on Raspberry Pis, I can deploy the same app. I can deploy it to 20 Raspberry Pis. And yeah, I can pull the plug. And I can expect things to stay running. That's valid. But it really doesn't matter if your database is down, right? I could have hundreds of apps, but if my data store, my data tier is down, that's not really providing a lot of value. And now in this competitive market, latency, downtime, I think we have figured out. But latency becomes more and more important. Yeah. For a lot of conversations that I have around data, it's like, hey, how come this is happening? We're having some unexpected behavior, or we expected this data store to perform at this level, and it's not. 95 times out of 100, that conversation always came down to this. This is another gem, and you're not going to need it out of the gate because the Spring team provides same defaults. Great place to start. But you are allowed to change the default configuration. You can change the number of threads. You can change the amount of memory that's being reserved. You can do these things, and I am concerned too. Like, I understand, hey, I got these defaults from the Spring team or from the vendor. I'm going to use those defaults as long as I can. And I would rather scale out to 100 instances and use the defaults than to have what I need provided by one VM or two VMs with some config changes. There are times in my career where customers said, hey, much like your organization, Tim, where the customer said, our latency is 4 milliseconds and we can't operate at 4 milliseconds. We're losing money. It's costing us millions. We need to get our latency down to 1 millisecond. Or on the other hand, the customer says, our latency is 2 milliseconds. But they're limited on another thing, the number of transactions that they can do during a day. Think financial institution. The number of transactions that they can do in a day is limited because their latency is 2 milliseconds. If we can get them from 2 milliseconds to 1 millisecond, they can make how much more money? Yes, twice as much money, right? If that's your limiter. Latency is the new downtime. If it's 4 milliseconds when it could be 2, that becomes critical to the people that are paying the bills. Right? Yeah, maybe. Go ahead.
Sometimes you can reduce the latency that much, double your capability.
Sometimes.
You're still going to end up with 2 milliseconds latency, and you can still scale, and you can still double your transaction volume.
Yep. Yep. You have all sorts of options here, right? He said sometimes you can reduce from 2 milliseconds down to 1 millisecond and get that twice as many transactions per day. Sometimes you could scale out, like maybe deploy to another region and get more scale on your data store. So you have options. That's a great point. So I'll pause here and I'll say one thing that I always say. When you come to my house for dinner, if you leave hungry, that's your fault. When you come to my house for dinner, if you leave hungry, that's your fault. Here in this session, I've got a mic even, that if you got questions, I want you to raise your hand. All right? I want you to get your questions answered. And if I don't answer today, I'm here all week. All right? Is that fair? Head nods? All right? And when you get my invite for dinner, you know. So, you might not run into this one today, but there's going to be some point where you're saying, hey, this transaction is taking too long. You've got the observability, like we just saw from Jonathan. And you're like, oh, wait, how come my latency is here? Check the connection pool. Check the connection settings. Hidden gem. Don't be afraid to fight that fight. It's worth it. Spring Cloud Stream. This was a kind of game changer, and I'm just gonna lay it out. We're doing the relational database approach. We're saying, hey, yeah, this works. We've been doing it for years, and by default, we would always kind of lean in to like the third normal form. Oh well, an order clearly has line items, so let's make another table. And we would do this all the way down so that our simple pet adoption clinic had 80 tables. Nobody else has made that mistake, just me? Oh no, it's there. Okay. Whew, thank you. So we understood, right? And there's problems when you do that. How many transactions does it take? And every time we do a join. Well, then this web scale databases started to come along, and we started to get these reactive clients where, hey, this is easy. We can go a little bit faster. We're seeing some really cool improvements. Things changed. But we weren't able to do the same thing. We weren't able to format our data in the same way. We had to realize, hey, not everything needs to be in that third normal form. We had to kind of shift our thinking a little bit to the point where some solutions, you'll hear me now, listen to me later, some solutions are really just, let's remove the joins from our relational database. Let's denormalize some of that data and see what kind of performance improvements we get. Yes, so try to put a graph database in third normal form. Who's doing that? Nobody's doing that. I mean, somebody's surely done that. Are you? No, therapy. It's a safe place, too. It's a safe place. So you can't. I've been told I can't many, many times. That doesn't say I didn't try. Right. Spring Cloud Stream was this idea that I didn't have to have like a transaction happening. I didn't have to do it synchronous. Spring Cloud Stream opened the door to event-based messaging, these event streams and the event-driven architectures. One of the other folks, I think you said you wanted to hear about Spring Monolith, right? Was that you? Somebody right there. One of the things, so this is Oliver's project. You've probably heard of Spring Monolith. One of the things that kind of comes out of that project is the idea that everything has to be in a relational database. It's kind of the default, and it has been the default for decades. But Oliver's research, Oliver's project, Spring Monolith, what he's learned and what we're saying, is don't start that way. These event-driven applications, the event-driven architecture allows you to start in a monolith, but then also scale out. One of the problems that I saw a lot with the early adoption of microservices was we had like a microservice apps, but they were all connected to the same database. Or even if it was a different schema on this, it's not the same data, different schema on the same database, but they're still at the scale, of millions of transactions a second. You're still hitting that same database. You're still causing problems. So much in one of the situations that I was in during the week, we had one format. Our transactions look like this, but on the weekend, it was very, very different. On the week, we were read heavy. On the weekend, we were write heavy. And every Monday we'd come in and we can't understand, how come our database is falling down over the weekend? We didn't have that much traffic. And the DBAs go around and they readjust, we're going to optimize it for the reads. No problems throughout the week. And then on Saturday, how come these writes we didn't have that problem last week. We were literally optimizing the same database for reads and then stepping on our own toes and then re-optimizing for writes. Because at scale, that happens. So the Spring Cloud Stream, you don't have to start with relational databases. I'm going to say that. Think ActivePassive. I already said that. But this idea that I could have my data moving around, it didn't have to live in one place.
The biggest challenge with data stores is if you're active, how do you synchronize the data?
The biggest problem with data stores is if you're active, how do you synchronize on the back end? I'm going to tell you this. Let your data store handle that for you. You don't have to come up with the algorithm, and I've seen people do it. You don't have to come up with the algorithm to figure out how we're going to make sure that a write over here fails if that data doesn't get replicated. You don't have to figure it out. Most of your active able data stores have that figured out for you. And Spring Data is going to make it so that you just get it out of the box. So I use Gemfire as the example. With Gemfire, I don't even know what the algorithm is. One of them says, hey, I'm going to write here the replica in this region. I'm putting you guys in 2 regions. The replica in this region is going to get written to, is going to get a copy of it. So now I'm feeling pretty good. I've got a copy, but then that replica is going to write to the leader in this other region. So I'm feeling good. And that time, if depending on the database, fast, or it could be multiple regions, right? Maybe it's not just one. But once I get to another region, I'm good. Then I can act. So as soon as I've written to my replica in my region and the replica is written to the leader in another region, I'm feeling pretty good. So that if this region goes away, I still have that data. So depending on how you do it, you might add latency, or you might say, I want to write to both at the same time and have some other algorithm figure out which one wins. Right? There's tons of approaches. Spanner says, we're all going to tie to the atomic clock, right? So it gets written and the time slot matters, and that's how they're doing the synchronization. So again, you brought it up. This is a fun little side note. With Spring Monolith, one of the things when you're doing event-driven things is know that if you're expecting your event to be delivered once, hey, it'll only be delivered once. It's in a transaction. That works. But you've got multiple instances listening for that same thing. Here's a problem that I've heard from customers. The clocks were off by so much that it was getting delivered multiple times. Was that in your talk? Slightly different variation, but this idea, right? Like timing is important. So yeah, it's baby steps. Spring Cloud Street changed the way I looked at my data tier. That combined with denormalizing the data and just saying, hey, I've made a change. Whoever wants to listen to it, let's do it. We kind of got a little bit of that this morning. Choose the right backend for the job. A lot of data stores, a lot of the options, whatever's on the menu, that's what you should use. Don't go and look for a graph database if your company has never done anything with graph databases before, right? Unless it's a solution to your specific problem. Does that make sense? A lot of the data stores that we have today have multiple capabilities built into them, like the vector store. You have options. So, yes, I can use Oracle for queues and vector stores and relational database and documents. Yes, it might not be the best at all of those workloads, but it works. And if it's on the menu, fantastic. But one of those use cases where you're using a document store, you're going to find that, hey, we need 2 millisecond latency. And Oracle may not be the right option for that. So you find another data source. So what I'm saying here is it's okay to use whatever's on the menu first. You don't have to jump, especially if it's a new product, you don't have to jump to the next thing. Use what's on the menu first. Whatever your company, your org is providing, use that first. We've done crazy, horrendous things with relational databases over the years, and it'll be fine, right? Until it's not. Until you need to save money, until you need to have that lower latency, then switch. But I promise you this, for most use cases, there's a data store that will give you the performance and the features that you need for your use case. Is that cool? So it's not necessarily a hidden gem. This is just old person advice, but I'm not that old. This is a question that came up. How many people are using Spring Data? We said Spring Data. How many are using Spring Data JPA? Yes, yes. How many are using Spring Data JDBC? Good, good. One of the questions that comes up a lot, Spring Data JDBC, and I'm thinking maybe it's because of Josh, has gotten more and more popular. I'll tell you the story for me. Hibernate, object relational mapping, getting out the door quickly. Oh, I've got an entity, it looks like this. I can even have Spring Data JPA build my schema. So I can make changes to my entities and have it generate the schema and make updates. That's fantastic. At certain points of our maturity, that's a great way to go. But the trade-off, as our pet adoption store gets 88 tables or whatever it is, those joins and those relationships where we don't know how those queries are being generated, we're leaving that up to the ORM. We're leaving that up to the database to give us a plan back so that we can see how these are going to work. But it's not consistent. And over time, that becomes a problem, right? At scale, that becomes a problem. The ORM is great to get us out the door, but then at scale, what it's doing for our third normal form of data becomes not so valuable. And again, my experience was, hey, this is exactly what was happening. So we needed to find a way to go straight to the database, send it the query that we were going to use, so we had a consistent result every time. Spring Data JDBC, in my head, from my perspective, this is that jump. Making that jump from, hey, I'm not just trying to get something out the door. I want to start with a little bit better approach. Maybe I understand the domain a little bit better. This is what I choose. But I said I like to use Raspberry Pis. So this is definitely a hidden gem that if you're in a position where latency matters, where performance matters, where cost matters, I'm gonna tell you this. I don't have the demo, but I'm gonna tell you this. If you generate that pet adoption repository that we did earlier today, if you use Spring Data JPA for a simple example like that, and you try to use native processing, the native image stuff that you get with Java 17, that you got with Spring Boot 3, how many people are using native images in GraalVM? How many people have never heard of native images with GraalVM? You've heard of it, but we're just not taking it to production. So for me, this was exciting. Raspberry Pis, GraalVM, native image processing, it takes that bytecode and it's going to compile it down to native code. For me, in my Raspberry Pis, I could deliver enterprise-grade, production-ready Spring Boot workloads on $35 devices. That was really exciting for me because I could compile it down to native ARM64 code. And in the cases of data, this is pretty cool. There are some use cases, depending on what you're doing, there are some use cases where the native code is actually going to outperform the JVM. So again, at scale, these types of decisions matter. So I'm going to pause. I'm going to say this. You always have a choice to make. And from the moment that you start whatever project you're working on. But also, I think I said it already, the right answer changes over time. So I'm going to give you 3 things I want you to think about. I want you to think about the JVM. The JVM that you're using, what version are you on? We get a new Java version every 6 months. We get a new Spring Boot version every 6 months. Maybe it's a good idea. We heard from Netflix earlier. Their upgrade process, just by switching and being able to use the latest JVMs, they're getting 20%. I don't know what that is at Netflix scale, but it's more than Raspberry Pi money. I know that much. So getting that upgrade, there's no company anywhere that says, hey, we just spent a bunch of time working on this brand new feature, but we want you to use last year's model. No company's doing that. It's hard to maintain the older stuff. So JPA or the JVM, I want you to consider from here forward, hear me now, listen to me later. I want you to think about the JVM that you're using. Then I want you to think about the data store that you're using. These are choices that, hey, it might have worked at one point. It might have worked to get you to, B series funding or to, IPO. But I want you to think about that. And then I want you to think about your path to production. If I do make a change from Oracle to Redis, how is that going to impact our product? How is that going to impact our company? So just 3 things, not hidden gems, not data related, but 3 things, just experience that I want you to think about. So the difference between JPA and JDBC, there are many. One of the other pieces, the records, being able to use records with Spring Data JDBC, we're in this kind of new era of how we're handling data. And things that are delivered as records is a little bit more consistent. I can spit that out as JSON and we're on with our day, right? And a lot of stuff that we're doing with Spring AI. The format of the data coming in and out. It's going to be in JSON. Easily throw it into a record. So these are considerations. But if you're going down the native approach, or if you would like to think about it just by converting to Spring Data JDBC from Spring Data JPA, you're going to have a faster startup time. You're going to actually have a faster compile time. The native image processing, the ahead of time processing that GraalVM does against Spring Data JPA, because of all the reflection that it needs to do, it takes longer to compile. So compile time, startup time, and your memory footprint with Spring Data JPA, small, simple case, is actually going to be larger than Spring Data JDBC. So just simple cases again. On a Raspberry Pi, when I only have 512 megabytes, each megabyte matters. Make sense? Small things. These are little tips, something for you to think about. I'm not going to go to questions yet. I'm going to go to the one demo that mattered to me, that I cared about. I started up this thing. At a certain scale, things matter, right? The changes matter. So what I did, this is on my GitHub. All I'm doing is loading some CSV data. I'm going to use the same library to pull in CSV data. Is anybody using CSV data anymore? Like, is that still a thing? One of the use cases that I had was like, yeah, our third party, our partners, at the end of the day, that was kind of the batch workload. It's like, oh, they're going to send a CSV somewhere and it's going to show up in our data center. Well, processing that CSV, yeah, it took time and it mattered, especially at scale. If you're getting 1 million of them a day, that matters. So I care about having the fastest CSV parser, having the fastest way to get from that CSV down to the data. Maybe I'm making money on each one of those rows. But I do this example. I'm using Spring Data, Redis, and Spring Data, JPA, to do the exact same thing. So here's a CSV file, read it in one row at a time, and put it into this object. Make sense? Simple enough? And we're going to take a look, and we're going to try to figure it out. We'll cross my fingers. I didn't actually execute it before I got up here. I have some other examples, but let's go. Let's do this real quick. Actually, I don't need to do that. Let's go take a look at this code real quick. So I'm implementing both data stores at the same time, which is also pretty cool. You're going to do it if you have any kind of cache in front. You're going to do that anyways. Again, it doesn't seem like it's that big of a deal, but just how easy it is to deliver Redis and an Oracle or Postgres or whatever to the same application. Yeah, it's kind of nice. I didn't have to think a whole lot. Here's my domain object. So I have a base store. This is the store. This is the information. This is the stuff that's the exact same across both implementations. Base store. I'm going to extend from that base store. Once I'm going to do it for JPA, and I'm going to say, hey, here's my ID. Here's how I'm storing this information. Extending from that base store. This is an entity. This is for Spring Data JPA. It looks like this. Everybody's agreed? We're following me? Fantastic. Now we're going to do one for Redis. Only change. I'm just changing the ID, how it's being stored. Here's my annotations. The base store is all the same. So everything is as similar as it can be. Fantastic. And then have a parser. I'm going to load the data the same way. This question came up earlier, like, hey, if I've got two different implementations that are doing the same thing, should they be in two different code bases or one? That's one of those interesting decisions, right? In this case, I put it all in the same. I said, hey, I'm going to call this Redis load or the JPA load. But you can see, if you take a moment, do you see that? We're doing the same thing. Convert it, store it. I'm doing one row at a time. I'm not optimizing one over the other. I'm just saying, hey, one row at a time. Let me get all the bits and let me store it. Make sense? Easy. Convert, same stuff. Anything else interesting? Let's go back and let's see what we're supposed to do. What is the point of this demo? So the first thing I'm going to do is I'm going to time this load. There's a Docker container that's been stood up. It's Postgres, only been ran once. Like we just started up. I'm going to load this data. I'm going to call this endpoint. I'm going to do it from the command line. Actually, I'm going to start it up again. And I'll do it in a new window. Time. Uh-oh. It says 80. Oh, is it not running yet? Let's try that again. All right, so it's loading. I think the data is like 64 megabytes of, this is retail store data that you can pull off of one of the .gov websites. Just retail store data. So your Walgreens, your Quick Trip, whatever it is. And all it's doing is one by one, loading it. Now the database is a Docker container that's running. I did Docker compose up. So it's right there. It's got a volume. How long do we think it'll take? 64 megabytes of data. How long could it possibly take? Who knows? I haven't ran it on this machine. I have no idea. It might take 20 minutes. We might be here all night. But we'll see. So we'll take that time. When you see a time on there, then we'll stop. But any questions so far? Anything interesting? Did this conversation bring anything to the top of your mind? Yes? No? Yes?
Yeah.
Difference in coding with coding to Spring Data JPA versus coding to Spring Data JDBC.
Yeah. So in the 981 days that I've been in this role, I have changed my mind on a lot of things. And remember at the very beginning, I said Spring Data and the abstractions. You get a lot of similar feel with Spring Data, no matter which project you're using. One of the cool things, one of the misconceptions actually, is that if I'm using Spring Data JDBC, that I can't get access to all the repositories, the nice repositories that I have access to. You still can. You can still have all the benefits of all the repositories, all the cool new repositories. How many people are using list repositories? Oh, well, here's another gem. Yes. For a long time, everything when we wanted a collection, we would get it would be iterable. I don't need this mic, right? I have this one. Sorry. Everything would come back as an iterable. And for swoop, what happened over there? For certain scale, the iterable works. For others, it doesn't. We do the find all, right? You had a little bit of extra work to do. If I'm bringing it back as a list, it's a list. I can move on. I can go. I can get the size. I can inspect it. I get a lot of benefits out of that. So here's another hidden gem. It wasn't on my list, but this is one. I want you to check out the list repositories so you can get your collections back as a list instead of an iterable. Sound good? That's a good one. But the question was like, hey, is there a big change? And I'm going to say there is change. You have things that you can do and can't do. There are benefits, but there's not a real big learning curve. Again, and this is from experience, talking with customers just like you. Oh, let's see, what did it say? 2 minutes and 50 seconds. That's not too bad. 64 megabytes of data that's running on a stuff that's running all sorts of other stuff. Learning curve, not big. I've helped teams make that move for certain reasons, right? But if you don't need to make the move, here's another thing. When we got to virtual threads with Java 21. A lot of customers, a lot of the community was like, should we move everything over to virtual threads? Should we convert all of our reactive stuff over to Spring MVC? The answer is no, right? You don't need to make changes just to make changes. But if you are running into a problem and this was a benefit to you, then yes. If you're already using a blocking stack, imperative stack, turning on virtual threads is going to give you more benefit. It's going to give you benefit. So if you're already there, cool. But if you're on reactive and you're wanting to change just to change because now you have virtual threads, my advice is no. Same with JPA and JDBC. If things are working with JPA, don't go and rewrite because I said it might be a little bit faster. Wait until you have a need. You have a follow-up? You'll find where you get the, hey, are there differences in coding? It's similar. You still have a lot of annotations that you get to leverage. You get to leverage records. So you get to leverage a lot more of the language capabilities that come with the new releases of Java that we're getting all the time. So that's my answer. Hopefully that helped. Fantastic. We're going to run the second one. This was 250. Does anybody want to guess how fast this same thing is going to load with Redis? Again, just Redis in a Docker container on the same. You want to take a guess? 50 seconds. 500 times faster. What would that be? That's 170 seconds. 500 times. Even if it was 170 1 second, it's probably not that much. But I'm guessing it'll be a little bit faster, but I don't know. So this time, instead of load JPA, we're going to say load Redis. And hopefully this example is just an idea of like, you can make changes. I can handle the same use case in many, many different ways. I showed you the code. It really depends on your use case. What are the benefits that you're getting from that data store? What are the trade-offs? But Spring Data's abstractions allow you to make changes. It allows you to evaluate the differences between your data stores easily. What was it? 23 seconds. So 10x faster. That's pretty cool. So with that, I'm gonna encourage, again, if you come to my house for dinner and you leave hungry, that's your fault. I'm gonna be here all week. If something comes up later, I feel like I missed a slide because there's another project that I want to talk about. Once you get into this idea that my data can go between different data stores, have you ever heard of Spring Cloud Data Flow? Spring Cloud, we have a couple of it. Have you used it yet? Once you start to realize that your data can move, Spring Cloud Data Flow is a tool that allows you to kind of like connect the dots. I want to take my read from this Oracle database and I want to send it over here to this Redis database. I want to prefetch data. I've got this database that's being overwhelmed with requests. Maybe it's security credentials or something that's being overwhelmed with requests because every request has to go to the security server. So instead of going and hitting that database, I prefetch. I say, hey, anytime there's a change to that database, send it out. Send it out to that Gemfire so it can go faster. So I'm not overwhelming the expensive database and I'm providing better latency at scale. You have these options. Spring Cloud Data Flow, that's just one. I can handle logs, I can handle events, emails, etc. Spring Cloud Data Flow is just a really, really powerful tool. If you have not taken a look at it, I highly recommend it. And yeah, I'll be here all week to help you. That was the last thing. Sorry I missed that slide. But if there's any other questions, I'm here to help. Thank you so much for your time. I hope that you guys are having a wonderful SpringOne. Yeah, thank you. My name's John.